Okay, we're graphing square root and cube root functions. So if you haven't watched the first video, I would recommend doing that first. Let's go ahead and look at example 2. I know this is tough. Do the best you can. Hang in there. We will get through this one way or another. So if we look at this example 2, what I notice is that our HK, let's zoom in, our HK is at 1, remember H is the opposite, 1, 2, and our A value is 3, so it's not reflected, but we have a vertical stretch. So if I look at the parent function, let's do that one in yellow again. The parent function starts at 0, 0, and it's 1, 1, 4, 2, 9, 3. So this is kind of the inverse, not kind of, it is the inverse of our quadratic function. It looks something like that. Now if I am to shift the HK by H and K, the 1 is a right shift and the 2 is an up shift. So I go right 1, up 2, and there's the new point where I start. And now there's a vertical stretch by a factor of 3. So where we'd normally go over 1, up 1, I'm going to go up 3 from that point. Okay? So 2 plus 3 is 5. That's how we ended up there at 5. Let's redraw that. From the starting point, I would normally go 4, 2. So 4 from there is 1, 2, 3, 4. So I'm at 5. And now I'd normally go 4, 2. So I need to stretch it by 3. So I'm going to go up 6, 3, 6. And 2 plus 6 is the 8. So I'm comfortable with the 8. 1 plus 4 is the 5, so I'm comfortable over at the 5. Then the last one should be 9, is normally 9, 3. 9 out gets us all the way to 10. So up 3 would be 3 times 3, that's going to be up a total of 9. So here's my 6, 3 more is 9, and I'm all the way up there. So I'm going to connect it, and there it is. What a thing, huh? What? If you need to go back and rewind and look at that again, go ahead, please. If you wanted to build a table, it's not impossible to build a table. What we want is we want values for x that's going to give me a perfect square. So remember, we have, let's try this again. Get that 5 out of the way. So I've got 3 square root x minus 1 plus 2. So I need that x minus 1 to be a perfect square. So this is where the table gets a little complicated. For x minus 1 to be a perfect square, well, I can't do 0, because 0 minus 1 would be negative, and I can't take the square root of a negative, but I can do x equals 1. Keeping in mind x minus 1, when I put in 1 into x minus 1, I get the square root of 0 plus 2. So my y value is 2. Normally I would want a 4 inside, but if I put 4 into x minus 1, 4 minus 1 would be 3, so I need 5 minus 1. So we put in 5 for x, 3 times 5 minus 1, which is 4, which is 3 now times 2 plus 2. 6 plus 2 is 8. If I go one more, I need a 9 to be under the radical. Well, to have 9, I need 10 minus 1 is going to give me 9. So x has to be 10. I have 3 times 10 minus 1. 10 minus 1 is 9. Square root of 9 is 3. 9 plus 2 is 11. So these are those ordered pairs I plotted, if you can believe me. X is 1, y is 2. X is 5. Sorry about that. X is 5, y is 8. X is 10, that's a 10, y is 11. So those are the ordered pairs that show up on that green graph above. This is not easy stuff. Hang in there. Don't give up on me. Let's look at domain and range. So our domain is the possible x values we can use. How many colors can I add to this? Our domain starts here at x equals 1 and it goes out to infinity. So our domain is going to be 1 to infinity. Our range, let's use dark green. Our range, or our y values, go from y is 2 up and up and up. Y's do this, so our y values go from 2 to infinity. Our transformations, we went right 1, up 2, so it's a shift. Wow, let's try to write legibly. Shift, or right 1, up 2, and a vertical stretch by a factor of 3. How lovely. Our end behavior as x goes to negative infinity, y is undefined. We don't have any values over there at negative infinity. And as x goes to positive infinity, y goes to positive infinity. End behavior is not so tough. If it's messing you up, it's probably just because the other things are a little bit weird. So we can work on end behavior next time you see me. All right, let's keep trying. Let's go ahead and look at number 3. If you need to pause and rewind, please do that now. Let's go with blue. So here, my HK, remember H is the opposite. So HK is not, H isn't positive 3, it's negative 3, but K is 2, positive 2. So this tells me my starting point is left 3, down 2, and my A value is negative 1/2. That gives me a rocks and a vertical shrink by a factor of 2. So let's zoom in, and hopefully we can get everything on there. So remember, the parent function starts at 0, 0, and it's a square root function. So the first square root of x is 1, and it makes y 1. The next perfect square is 4, square root of 4 is 2. The next perfect square is 9, square root of 9 is 3. So I'm putting in perfect squares for x so that I can get integer values for y. And that's the line y equals square root of x. Now that's not what we're graphing for this problem. We're graphing something quite different. And this quite different starts at negative 3, positive 2. So it's going to start right here. And it's that negative is going to shift it down. and it's going to shrink by a half. So instead of over 1, down 1, we actually are going to be at a half. Not much fun. About right there, maybe. Normally we would do 4, 2. So I'm still going to do my 4, but I'm going to do half of 2. So to go 4 from -3, I end up at +1. And I end up right there, 1, 1. Normally I'd do 3, 9, or sorry, 9, 3. So if I go out 9, that's going to put me out here at 6. 1, 2, 3, 4, 5, 6. And I normally go down 3 from there, but I need half of that. So I'm going down 1.5. And my next perfect square is 16, and I don't think I can get there. So let's sketch this in. Now, if we were to look at the tables, you can always graph using a table. I'm going to give myself a little more room this time. After we plug in for x, we need to add 3, take the square root, multiply by -1/2, and add 2. How crazy is that? So remember that I'm looking at this x plus 3. So to get 0 in for x plus 3, I need x to be -3. So -1/2, -3 plus 3 is 0. So I have 0 plus 2, and y is 2. And we see this right here. The next square root I can get under the radical is 1. And for x plus 3 to be 1, so you could even solve it algebraically if you want, but x is going to be -2. -1/2 square root -2 plus 3 plus 2, so that's 1. -1/2 is going to be positive. The result is +1 1/2. The next perfect square I want under the radical is going to be 4. So I need x to be 1. So -1/2 times 1 plus 3, which is 4. When you get that math done, you should get 1. Sorry, I didn't give you those points. So the second point we graphed is there. And this third point, x is 1, y is 1, is right there. How much fun is that? And finally, the last perfect square I'm going to try to get is 9. So to get 9 into the radical, I need to put in 6 for x. So 1/2 square root 6 plus 3, then plus 2. So square root of 9 is 3. Half of that, -1/2 times that is -1.5. And the result here is a half. And this big mess right here gives me that point there. So our table kind of confirms that we graphed it correctly. You do not have to make a table. It's just there to help you. Running out of time, so I have to go through this pretty quick. The domain is your x value. So our domain starts at -3 and goes on and on and on. So -3 to infinity, that should be an angled bracket. Our range starts at 2, or goes from 2 to -infinity. Remember, we're going to write the -infinity first, lowest value first. And our transformations, it looks like we went left 3, up 2, vertical shrink, and a rocks.